Good evening, everyone. Welcome to our second to last session of ACT Prep. Tonight we'll be finishing up science, and then Tuesday we will do the writing portion, and we will be done. I've really enjoyed doing this class with you. It's been a great few weeks, a learning experience for me as well, and I hope you've gotten something from this course. And please, like I said before, any feedback you can give me would be greatly appreciated. So tonight what we're going to do is finish up the science slides. We'll just talk a little bit more about the different passages and different types of questions and how to tackle those. And then we will go over sets 1 and 2, or passages 1 and 2 that you did for the assignment since Wednesday. And we'll talk about the passages and the answers and any questions that you might have. So we will start by finishing up the slides here. Okay, so we left off, we were talking about data representation and how that looks for on the passages on the ACT. So there are two terms to be familiar with for graphs on the ACT. Interpolation means to estimate values between two known values found on a graph. The ACT may ask you to guess or estimate a value of an unknown point between two given points. That's just one type of question that may appear on the data representation passages. Extrapolation means to project or expand known data into an area not known. The ACT may ask you to extend the line on a graph. So they'll, say if you kept doing this experiment for 2 more weeks, what would your outcome be? So they want you to kind of predict how the trend is going, what that's going to look like. One more tip for data representation. If two answer choices are opposites, start with them first. There's a good chance that one of them will be the correct answer. And this is usually the case for a lot of different sections on the ACT as well. If you look at something and there's two answers that really stand out that are direct opposites, chances are one of them's on there to kind of trick you because it's the opposite of the correct answer. So start with those, look at those two, see if one of those could be the correct answer, and then go from there. Okay, research summaries, we talked about that on Wednesday. This is the experiment passage. They're going to tell you about an experiment, how it was done, what were the variables, what were the outcomes, what was used in the experiment. So this is just basically, can you read about an experiment and understand it? There are always 3 research summary passages on the ACT, followed by 6 questions each. Remember, data interpretation had 5 questions, research summaries have 6 questions, and the conflicting viewpoints or battling scientists, the ones that have more than one view on something, will be 7 questions. So that's a good way to remember which passage you're reading for the science portion. The research summaries will have 6 questions. They usually contain an introductory paragraph followed by a number of experiments. They may include graphs, tables, or charts. So it'll be a little introduction on, what was the experiment, what was their goal, what did they use, that sort of thing, kind of tell you a little overview, and then it's going to break down the experiment for you. You want to start by figuring out the objective of the experiment. The objective is the statement that tells you what the purpose of the study is. So it is usually found in the beginning of the introductory paragraph. Knowing the objective of the experiment will help you stay focused while reading the rest of the passage. So this is just a good way to kind of say, okay, this is what I'm looking for. This is what the objective is. This is what they're going to try and teach or come across in this experiment. So that's just kind of a good overview, just like all the introductions for all the passages that you read in the ACT. It kind of just gives you an idea of what to look out for. So it's good to read that, kind of have that in your mind. Look for differences between the experiments in the passage. What procedures did they do differently? Also note the variables in the experiments. You may need to identify the relationship between them. And then finally look at the results of the experiments and note any similarities or differences. So when I say experiments, I don't mean that it's two people doing two different experiments. It might be one person doing one experiment and then changing one thing in the experiment and doing it again. So you really want to notice all the differences between the experiments, or the trials sometimes as they might be called, and see what's changing and how did that change the outcome, that sort of thing, because the questions might ask you about that. Okay, conflicting viewpoints. There's only one conflicting viewpoints passage on the ACT, and it's followed by 7 questions. So it's a little bit longer, and there are more questions, but there's only one of them. 2 or more conflicting views on a scientific phenomenon will be presented. And some of the examples I gave you last time were like what caused the dinosaurs to become extinct, or what caused the continents to take the shapes that they have, that sort of thing. And it's going to be something that really isn't a mystery anymore, but it could have 2 different views, 2 different scientific views on something. You will need to understand each viewpoint and how it is similar or different with the other views. Most of the questions will ask you to compare and or contrast the theories given. So it's important to know that it's not always going to ask you the differences. A lot of times it will ask you how are they the same, or what do they agree on. It might ask you, and I don't know if this was one of the sets that we did for today, I think it was, there were a few questions that asked what, of the following statements, what would the 2 scientists agree on? So a lot of times it's how are they the same. Other times it is how they're different, but it will always ask you some sort of compare and contrast question. You want to look at the questions first and then do questions with corresponding viewpoints, and save the questions that deal with the 2 or more viewpoints for the end. So what I mean by this is, you have your first passage or your first viewpoint, and then you have your second viewpoint, and then you want to look at the questions that deal with the first passage first, do those. Then you want to look at the questions that deal with the second viewpoint second, do those, and then do the ones that talk about both of them at the very end. This will just help you kind of keep track of the information. So if it just talks about the scientists in passage 1, read passage 1, do those questions. Then read passage 2, do the questions that correspond with passage 2, and then at the end, do the ones that correspond with both, or ask you to compare and contrast both of them. It is important to understand not just how the viewpoints disagree, but also how they are similar. So we did talk about that too. It will ask you about similarities. So be on the lookout for that as you're reading the passages too, not just how they're different. And you should also be aware of the strengths and weaknesses for each argument. I think I said last time that it's never going to ask you your opinion on the issue. So you don't need to worry about that. But one of the scientists might have a stronger argument than the other, or there might be a weakness in one of the arguments, and it may ask you questions about that. So that's just something else to be aware of, the strengths and the weaknesses for each argument. Finally, you want to make sure to consider how new information would alter each argument, i.e. strengthen or weaken each. So you want to make sure, sometimes they might say, dinosaur bones were found on this continent, how would that strengthen or weaken the arguments? Okay, so they might give you a little bit of information and say, would that strengthen scientist one's argument or weaken scientist one's argument? So they might just ask you to kind of interpret that, use a little bit of new information, and see how that would affect each viewpoint. Okay, that's just a blank one. So if there are no questions about the science questions, we will move on to the sample science questions that you had. So hopefully these weren't too difficult. I think the first one that we have are the 2 battling scientists, the conflicting viewpoints. This is probably a good one to start with. I tend to think these are maybe a little bit easier because it is just more reading comprehension. And I'm more of a reading comprehension person than a math and visual person. But again, all the information is here in the passages, so you do not need to know any outside information at all. So we'll start with this one. Now the directions say, The passage in this test is followed by several questions. After reading the passage, choose the best answer to each question and fill in the corresponding oval on your answer document. You may refer to the passage as often as necessary. And again, a reminder, and it tells you right here, you are not permitted to use a calculator on this test. You don't need to use a calculator on the science test, but even if you were tempted to, they'll tell you to put your calculators under your desk or, to the side, and you're not allowed to use it during this section. Math, yes. Science, no. Okay, so I'm not going to read these whole passages, but I will just kind of go through really quickly. And you can see that it kind of gives you a little overview here of what we're going to be reading about. And they're talking about one of Jupiter's moons and whether or not there is an ocean underneath the ice that covers the moon. And so we're going to have two different viewpoints on whether there is an ocean and why or why not that would be. So the first question asks us, which of the following best describes how the two scientists explain how craters are removed from Europa's surface? So right off the bat, it's asking us a question about the two scientists. So this is one you would want to wait until obviously you read both scientists and their views. So we want to know which one of the following best describes. So what does scientist 1 think and what does scientist 2 think? Which one of these things here explains how craters are removed? And the answer for this one is B. Scientist 1 believes they're removed by filling with water, and scientist 2 believes they're removed by sublimation. And it tells you right here, this is pretty much comes right from the passage word for word. Let's see if I can find it here. Let's see. It's been smoothed by liquid water, oozed up into the craters, and then froze. And then scientist 2 talks about sublimation in his paragraph down here. Let's see where it says. Sublimes, okay, into the atmosphere, quickly eroding and moving any craters that may have formed. So it really spells it right out for you. So this is information that you can just take right from the passage. And they're asking you to look at scientist 1 and scientist 2. So this is one that deals with both passages. Question 2 asks, according to the information provided, which of the following descriptions of Europa would be accepted by both scientists? So again, this is one where we just talked about how do they agree? What's something that they would both agree on? And the answer there is J. Europa is completely covered by a layer of ice. And they both do just say that in their paragraphs. So that's one way that they agree. With which of the following statements about conditions on Europa or the evolution of Europa's surface would both scientists 1 most likely agree? So here's another question. This is kind of a little rare that there are 2 questions right in a row on how the 2 scientists would agree. So they're asking us, what's another way that they agree about the surface of this moon? And the answer is A. It's being shaped by the movement of ice. Now, that's something they agree on. How the ice is doing it, whether or not there's ocean beneath, that's something that they disagree on, or they might have different viewpoints on, but they both agree that A, it is being shaped by the movement of ice. Okay. Which of the following statements about meteorite craters on Europa would be most consistent with both scientists' views? Here's another one. Again, this is not super common that there's this many in a row about how they would both agree. But again, it's kind of asking you the same thing. After reading both of these passages, what's one more thing that they would agree on? How are they similar? And the answer here is G. Meteorite craters, once formed, are then smoothed or removed by Europa's surface processes. Now, the processes that they're talking about are different, but they do agree that they're both smoothed or removed on the surface. So they disagree about something, but they do both agree that they are smoothed or removed. Okay, 5 says, scientist 2 explains that ice sublimes to water vapor and enters Europa's atmosphere. If ultraviolet light then broke those water vapor molecules apart, which of the following gases would most likely one expect to find in Europa's atmosphere as a result of this process? Now, I had a little bit of a problem with this question, because I do think you need some outside information to answer this question. And I've been telling you, you don't need any outside information. And this is kind of basic science information that you need, but still, it is outside information. So I don't know, I just had a little issue, I guess, with this question. But as you know, we're talking about water vapor. Water is H2O. So which one of these things, if it broke apart, would be in the atmosphere? And the answer for 5 is oxygen, because oxygen is found in water vapor. So again, most people know H2O is water, but I still kind of felt like, you know, everything that they tell you, everything that they ask you should come right from the passages. And this was a little bit of outside information, but again, it's, I guess, pretty basic science, so most people would know that. But that's what they're asking in that question too, is if it breaks apart, the water vapor, what's going to be in the atmosphere? Okay, question 6 asks, based on the information in Scientist 1's view, which of the following materials must be present on Europa if a magnetic field is to be generated on Europa? So the answer here is H, dissolved salts. And we know this because he talks about, or she talks about salty ocean up here. So they're saying, Scientist 1, if the materials must be present, a magnetic field, what needs to be present? And up here they talk about the magnetic field would interact with the salty deep ocean and produce a second magnetic field around Europa. So dissolved salts come from the salty magnetic, or help produce the magnetic field. It comes from the salty ocean. And then finally for this one, assume Scientist 2's view about the similarities between Europa's surface features and flowing glaciers on the Earth is correct. Based on this assumption and the information provided, Earth's glaciers would be least likely to exhibit which of the following features? Okay, so now we're looking at Scientist 2, and we are assuming that he or she is correct in what they believe and what they're talking about. So based on this assumption here, the Earth's glaciers would be least likely to do which of the following, and the answer is, or exhibit which of the following features. Meteorite craters would be our answer. Few meteorite craters are observed because Europa's thin atmosphere. Surface ice continually sublimes in this atmosphere and erodes quickly. So the other 3 things would be found on glaciers: pressure ridges, cracks, dark bands. The one that would not be present is the meteorite craters, are the meteorite craters. So this one I thought was a pretty good passage. You know, it's not too difficult to understand. The information's all right there for you, except for the H2O question. But again, I guess they assume most people would know that. And it is kind of rare that they ask like 3 questions right in a row about how they're similar. But like I said, it's important to not just notice how they're different, but how they also agree. So this is what you would find for the conflicting viewpoints passage. And like I said, there's only one on the ACT. It's a little bit longer and it has the most questions, but there is only one. So if this is kind of your favorite science passage, fortunately, this is it. There's one. But again, it takes a little bit longer too. There's a little bit more reading. So now let's look at passage 2. Kind of dissect that one a little bit. So right away, let's look at how many questions. And this will tell us what kind of a passage it is. So there's 1, 2, 3, 4, 5, 6. So it's research summaries, right? So they're going to tell us about an experiment and ask us some questions about it. Directions are the same. The passage in this test is followed by several questions. After reading the passage, choose the best answer to each question and fill in the corresponding ovals on your answer document. You may refer to the passage as often as necessary. You can't use a calculator. So the directions are the same, even though it is a little bit different. Here, obviously, what they say is a passage is some text, but also some charts and pictures as well, because they're describing an experiment. So it talks about a student studying how gases diffuse derived from the following formula. And it gives us a formula. When I was reading this, at first I thought, oh, this is going to be a little overwhelming. This is a lot of information here, and they're giving us formulas. But once I started with the questions are pretty straightforward, and they do come right from, a lot of them come right from the tables. So reading this, it might seem a little overwhelming, but remember we said sometimes you don't even need to read word for word the text. You can kind of skim it because a lot of the information that the question's asking you comes from the tables and the graphs and the charts. So those are the things you really want to focus on. You definitely don't want to skip over the text completely, but if you find it a little overwhelming, don't worry, focus more on the graphics, the tables, the charts, maybe a formula that they give you, because that will help you the most with these questions. So let's just kind of look really quickly. They're telling us, they give us a formula here, hydrogen chloride and ammonia. When they react, they form solid ammonium chloride. Okay, so that's just a little bit of information that we need. It's not super important, but it's there, so we can always refer back to it. Okay, and then it looks like there's one table here from one trial that they did. And then they give us a little diagram of they're sticking the cotton swabs in there and how they're reacting in the tube. And then there's another table here, so it looks like they did another experiment or another trial, and then a third table. So basically they did 3 different experiments. So what we want to focus on is how they're the same and how they changed. There's going to be at least one thing that changes in each experiment, or else why do the experiment again? You'll get the same results. So there's going to be at least one thing that's different and probably a few things that are the same in each experiment here. So let's look at the questions. Question 1 says, which of the following best describes the difference between the procedures used in experiments 1 and experiments 2? Okay, so they're asking us to look at the first 2 experiments. What's different? Okay, so I said there will be at least one difference between them. In experiment 1, the answer is A, the temperature was varied. In experiment 2, the diameter of the tube was varied. And that's pretty basic just by looking right here at the charts. So here they change the temperature. Here they change the tube diameter. So those are the 2 things. The time is something that they keep track of, and then the distance of the ring from the swab. So those 2 things stay the same. The thing that changes is the temperature in table 1, tube diameter in table 2. So the answer there is A. Okay, question 2 asks, which of the following sets of trials in experiments 1, 2, and 3 were conducted with identical sets of conditions? Okay, which of the following sets of trials? Okay, so now we're going to look at, in each table, the trials. So which trials were conducted with the same set of conditions? And our answer there is G, trials 1, 5, and 9. So the first one has the same conditions in each one. Trial 1, we'll look down here, trial 5, and then right down here, trial 9. Okay, same time, same distance, trials 1, 5, and 9. Okay, question 3. Based on the results of experiment 1, which of the following graphs best shows the relationship between the temperature and the distance of the ring from the HCl swab? Okay, so they're asking us, looking at this table, table 1, which of the following graphs best shows the relationship between the temperature and the distance of the ring? So as the temperature goes up, as the distance goes up, the temperature does what? So let's look here and see. Scroll down so you can see the first table. We can see as the temperature goes up, the distance kind of stays the same. It kind of hovers right around 4 centimeters, 4, 4.1, 4.1, 4. So even as the temperature goes up, the distance doesn't really change. So for 3, the answer is going to be D. Kind of stays. Remember we talked about a flat line really shows no relationship. So no matter what the temperature is doing, the distance stays the same. And that's D. That's what D is showing us there, that graph. Okay, question 4. If a trial in experiment 3 had been performed with the swabs 25 centimeters apart, the distance from the swab to the ring would most likely have been closest to. Okay, so now they're giving us another piece of information and asking us to interpret what would happen with that. So 25 centimeters. So let's look at experiment 3. So 25 centimeters. So that's going to be right in between here. And they're asking us the distance would most likely be what? So we're going to look at something that's kind of halfway between, since 25 is halfway between 20 and 30, we're going to look at something that's halfway between 8.1 and 12.2. And that is closest to 10 centimeters. So that's G. Question 5 asks, if another student wanted to test a factor that was not studied in experiments 1 through 3, which of the following should he do next? He should test how the diffusion rates of gases are affected by. So in other words, which thing have they not tested yet in these experiments? The answer is A, atmospheric pressure. They tested the tube length, they tested the temperature, and they tested tube diameter. So the only thing they haven't really talked about yet or they haven't tested is atmospheric pressure. So 5 would be A. And that's just kind of looking at the experiments and seeing here's distance, here's tube diameter, and temperature, no atmospheric pressure. So that's the only one that hasn't been tested. So that would be the answer there. And then the last one here, the student concluded that NH3 diffuses at a greater rate than NCl. Do the results of the experiments 1 through 3 support her conclusion? Okay, so this is one of those questions I think we talked about for different sections of the ACT where it's kind of a two-part question. First, you have to agree or disagree, say yes or no, and then why. Back up your reason. So first we have to decide, do the results support her conclusion, yes or no, and then why. And the answer here is J, yes, they do support her conclusion because the vapors traveled farther. The NH3 vapors traveled farther than the NCl vapors. So that would be why. And we can look at the distance, right, and see if they traveled farther. What we're going to look at is how far they traveled from the swab. So the answer there is J. Okay, so we're kind of done a little early tonight because the science slides did not take me as long as I thought, or the science questions. I thought they would take a little bit longer, but I guess we'll end early tonight for a holiday weekend. Again, I just want to say, if you have any questions over the weekend on the science, definitely let me know. I know this was an area that people were a little bit concerned about as far as what to expect on the ACT. What we'll do for next week is we will do the next two passages. Let's see, passages 3 and 4 here. Let's scroll up. Yeah. So we'll do passages 3 and 4 for Tuesday, and we will go over those, talk about those in a little bit of detail, and answer any questions you have on those. And then we'll finish up with the writing, and we'll just talk about what to expect on the writing, what you need to do for the writing. It's not a very long, you have 30 minutes to write one essay, so you don't have a lot of time. So it's important that you use your time wisely, but we will talk about that. Again, that is optional for the test, so not everybody's going to plan on doing the writing, but if you are and you want some tips, we will talk about that on Tuesday. And then that will be our last session, but what we'll do is I will ask you just to look at one of the writing prompts on this website and submit an essay. You can just email it to me. We'll talk about that next week, and then I will critique it for you. I will look at how I'll try to look at it through the eyes of an essay grader for the ACT and tell you what they would look for, what your strengths were, what your weaknesses were, and give you any information I can, any feedback I can on your essay. The only thing I ask is that you would give yourself 30 minutes like you would actually have on the test, because that makes a big difference. If you spend an hour, you can write a great essay, but you have 30 minutes to look at the essay prompt, think about it, brainstorm, and write. So it doesn't give you a ton of time. So anyway, we will just finish up there for today. I apologize for this being a shorter class, but it's nice out. It's a holiday weekend, so I guess go enjoy your Friday evening. I appreciate you joining me tonight. And we will meet here next Tuesday at 6 o'clock, unless a baby comes before then. But as of right now, I'm planning to be here. So we'll do our last session Tuesday, 6 o'clock, and we will finish up with writing and any other questions you have before the end of the course. And definitely email me at any time. Let me know if you have any questions before then or any comments. All your feedback is appreciated. So enjoy the long weekend, enjoy this beautiful weather, and I will meet you back here Tuesday for our last class, and we'll talk about the ACT writing. Thank you. Have a wonderful weekend.